is the integral of 1 over the square root of 4 minus x squared. I welcome you to try and just solve it on your own. However, this is new. This is a case of trigonometric substitution. My way of thinking about it that helped me make sense of it was the idea of what is the derivative of arc sine? Well, it's 1 over the square root of 1 minus x squared. It looks awfully familiar there. However, many people would like to use the Pythagorean identities as a way to explain it because we're about to make use of them. So that is sine squared plus cosine squared equals 1. What we could get here is 1 minus sine squared, or 4 minus sine squared, but that is not the identity. But we're about to make it work via change of variables. Recall what u sub is by theory. It is undoing your chain rule. I think there's some chain rule being used here. So, well, let's just go ahead and try substitution. Well, I don't want to make it sound random because the truth is it's not random. Usually you'll have, integrals are in a form like this. So I have a coefficient beside the x squared sometimes. This is b squared, the coefficient. X squared is x squared. But if you were to see a 4 beside the x squared, and not the minus 4, but a 4, then it is just going to be b squared. So 4, which implies that b equals 2. However, b is 1, so yeah, it just means that b squared is also going to be 1. And it can't be negative because then you'd have to take the square root of it, and you have to start working with complex numbers. I haven't tried it. It probably can work, but I haven't tried it. And then for 4, this is a squared. If you're doing a trigonometric substitution, you're going to want to set your x to be equal to, it's a squared over b times the function that you're going to recognize needs to be used. You get better at recognizing it just by doing it. Here, as I said, recall arc sine. There, we want to use sine here, but you'll see. X equals, well, a over b, so 2 over 1, but remember I am taking the square root of this number. So 2 over 1 is 2. 2 sine theta. Okay? Well, with u sub we have to find what dx is. Dx is equal to 2 cosine theta d theta. This is where it can get complicated because now we have an extra term added in. But it doesn't inherently make it a lot more difficult because you're about to see that it simplifies down quite a lot. So dx is now 2 cosine theta d theta all over the square root of 4 minus x squared. So exponents can be distributed through multiplication or through products. And so because we do that, we get 4 cosine squared theta. You can factor out of a square root, but you're going to have to apply the square root to it. So we can factor this 4 out of it. And what doing that essentially gives us is 2 cosine theta d theta over 2 times the square root of 1 minus cosine squared theta. And what I hope you'll notice is that this is just, I meant to put sine squared. That's silly. Sine squared, and then sine squared here. Okay, sorry. Mistakes happen. It's okay. Check your work. And so there, what we get here is actually the 2's nicely cancel out. This won't always happen, but if you're lucky, it does happen. And there, this is now equal to in theta. You have to remember that because we're about to start drawing a triangle. If you left it in X, you're going to have a bad day. And so there, we get cosine squared under the square root once you use the Pythagorean identity. And well, the square root of cosine squared is the absolute value of cosine. All over cosine theta, d theta. And so we're lucky enough to be able to say, okay, theta's going to stay in the first quadrant. Or, yeah, it's going to be, theta's now restricted from negative pi over 2 to pi over 2. This is fully fine. So now, because we set that, well, what's this? It's just theta. And so these two cancel out. Well, turn into one. They don't cancel out, but I'm sure you as the viewer understand them. And so there, the integral of d theta is just theta plus c. And so now what we have is theta plus c. You can solve for theta perfectly fine. It's the arc sine of x over 2, which you divide by 2 and then you take the inverse sign. So now, this is actually just equal to plus c. And there you've integrated that function. It does get more complex. Sometimes you'll have to leave it in terms of the inverse functions. It happens. It's okay. It depends on your instructor how they're going to grade it, though. Usually you can simplify it a lot more than you want to. So it's up to you. It's a valid answer if it's in terms of x. But sometimes you'll have to solve for a side of a triangle. For example, if I were to have a cosine or an arc cosine, I'd have to draw out the triangle and figure out this and that, and I'd be able to plug it in, because what we made here is actually just sine theta equals x over 2, and because of that, we make it a right triangle. So opposite over hypotenuse, opposite over hypotenuse. I hope I said that right. X over 2 sine opposite over hypotenuse. I said that right. And so you could solve for this one, and that should be square root of 4 minus x squared, which happens to be that. And it should always work out that way, I think. Don't hold me to that, though. And so with other trigonometric substitutions, like cosine, you don't do cosine. Cosine, you just don't do because it'd be negative right there. And at that point, you can just do the sine substitution. Tangent's a common one. That's going to be your x squared plus a squared. Yeah, s squared plus a squared. Secant is going to be your x squared minus a squared. I have to make sure I'm in the right terms because I don't want to say the wrong thing and mislead you. And the best thing you can do is try a lot of online examples. And I didn't include all of the substitutions that you can do. Paul's online notes is great. That's how I learned a lot of it. However, there are also other substitutions that you can do. For example, Euler's exponential substitutions. I believe they make use of the complex definitions of sine and cosine. Well, just of all the trig functions to work. There's the hyperbolic trig functions. Those also work just fine. My teacher for calculus-based physics, she said that she prefers to do hyperbolic trig functions over the normal trig functions. I want to learn exponential substitutions, so if I learn those, I will probably put a video on that. However, I have a few topics that I want to do, including an analysis topic and maybe eventually a video on my order theory study. So, I hope that's good. That's about all for now, though. Thank you.